So in the last one, we got to a few bottlenecks, like not understanding this, not being too familiar with this, and needing to go over this and needing to go over that too. That being said, we're going to start off with this preprocessor directive, because I think that's what this, and this all have to do with. All right. So let's make a new ChatGPT. We'll just do that over here. And let's say something like this. Regarding C++, in simple terms, explain this. Explain preprocessor directive and why we use, and let's get that notepad out, these three things right here. Let's do this, get these, slap them in right here, and say short answer. Short answer. Boom. All right. Ah, crap. We were supposed to do that in 4. Stop. New. 4. There we go. In C++, preprocessor directives are instructions that are processed before the actual compilation of the code begins. Okay. These directives tell the preprocessor to perform special operations, such as including a file or defining a macro. That's not too simple, is it? The if in def, define, and indif directives are commonly used together to prevent double inclusion of header files. This is known as an include guard. If in def, if not defined. Okay. If not defined, there we go. Checks if a unique identifier, like a macro name, has not been defined yet. What is a macro? What's a macro? Hold on. What's a macro? In C++, a macro is a fragment of code that has been given a name. Whenever the name is used, it's replaced by the contents of the macro itself. Macros are defined by using the define preprocessor directive. So here's an example. Define pi dot is a pi. Okay, define pi blah blah blah. In this case, pi is a macro representing the number this here. Okay. Whenever pi is used in the code, the preprocessor is, so it's a variable name. What? So it's a variable name for a function? Variable name? How about that? Not quite. A macro acts somewhat like a variable in that it can be used to represent values or code snippets, but it's fundamentally different because it's handled entirely by the preprocessor and not by the C++ runtime. What? Okay, how about this? What's the preprocessor? Right? What is this? Like, when do we get to the actual words we know? When can they break it down to something we can not have to look up other stuff for? The preprocessor is a tool that processes our C++ source code before it is compiled by the actual compiler. It performs several text-based manipulations, largely based on directives that begin with a hash symbol. Okay? These directives instruct the preprocessor to perform specific actions such as including other files, defining macros, or conditional compilation. Key tasks of the preprocessor include macro expansion, replacing macros with their respective values or code blocks as defined by define directives. So it's just a loop. What's a macro? What's a preprocessor? What's a macro? What's a preprocessor? Isn't that what's going on here? Well, let's go back up to what's a macro. I guess it's okay. The preprocessor is something that happens before compilation. Okay. Let's go back up here. What's a macro? In C++, a macro is a fragment of code that has been given a name. So it's not only, it's a fragment of code. So it could be a variable that equals a number, or I guess it could be a function. So a function can be a macro. So a function can be a macro. Yes. Anyway, it just does love talking, doesn't it? Anyway, I'm not going to read that. So that's what a macro is. Now we're up here again in the in-depth thing. All right. So these directives are commonly used to prevent double inclusion. So if in-def, if not defined, checks a unique identifier, like a macro name. So the name of a macro, okay, has not been defined yet. So it's just making sure that there's not a second macro name. Okay. So it goes through, okay, so if in-def, hold on. So if in-def goes through each file associated with the header, itself doesn't go through each file. Rather, it's part of a mechanism used within each file to prevent the same header from being processed multiple times. When we include a header file in multiple source files, or even multiple times within the same source file, we potentially run the risk of definitions being repeated, which can lead to compilation errors like redefinition errors. Here's how the in-def, define, and in-def directives work together in a header file to prevent such issues. Oh, man. Ugh. Okay. At the start of the header file, boom. This pair of directives checks if header file name H, this thing, usually a unique identifier related to the header file name, has already been defined. Okay. If it hasn't, it defines it. Okay. This way, the entire contents of the header file are processed only if header file name H has not been defined. What? This pair of directives checks if header file name H, usually a unique identifier related to the header file's name, okay, has already been defined. Okay. If it hasn't, it defines it. So this defines it if this has not been defined. So if not this, define it. Okay. Here we place the declarations of function types, constants, etc. Here we place the declaration. Oh, I'm running out of steam, honestly. Give me a second. Oh, man. Okay, back to it. So here we place the declarations of functions, types, constants, etc. So that's what we, okay. That's what's in the header file, yeah. Since the if in def check passes only the first time this file is included before header file name H is defined, subsequent inclusions see that header file name H is already defined and skip the reprocessing of the content. Okay, so it only processes, so this makes sure it only processes it once. Okay. At the end of the header file end if. This marks the end of the conditional block started by the if in def. Okay. This method is known as an include guard. This method, known as an include guard, ensures that even if a header file is included multiple times across different source files or within the same file, its contents are processed only once, thereby preventing multiple inclusion issues. I guess that makes sense. Although I would if we saw like the actual problem in effect, like what happens if we actually don't include it, that would be even better. But I guess we're just asking ChatGPT. Okay, show us an example of a problem if we didn't have it. Let's see. Let's finish reading while it does this. In effect, this doesn't require the preprocessor to go through each file, but rather leverages a simple check at the beginning of each header file to decide whether its contents should be processed or skipped based on whether they have been processed before. Okay? So let's see what it says here. Certainly. Let's explore a simple example to understand the problems that might arise if we don't use include guards in header files. Suppose we have two header files and one source file without include guards. Header file, mathutilities.h. And then this stuff, okay. And then header file, geometry utilities. Okay, so struct, what the hell is this? Struct point? Come on, bro. Why do you gotta keep doing this to us? Oh my god. Struct. It's got to be structure, right? Point. It's got to be an X and a Y on a grid, right? It's got to be, right? Got to be. Int add int A plus int B. Okay. So return A plus B is going to be what the integer. Is this a function? Is this how we make a? Is this in C? No, this is a header file. This is okay. Header file geometry utils h. Include mathutils.h. Double distance point A point B. Return square root of a.x b.x times a.x minus b.x. What the? I forgot math. So something squared, a squared plus b squared equals c squared. Okay, I remember that. Okay, I remember that. I remember how hypotenuses work. All right, source file main.cpp. So include math.utils and include geometry.utils. And then we've got int main point 0034. Int sums, add this, double distance, blah, 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 return 0. Okay. Problem scenario. Let's go. I don't want to figure this out. I know it's math, but I don't want to figure it out. And then the add 5, 7. Anyway. I feel like an idiot for not remembering. I know this has something to do with triangles. And it's the triangle, but what is this for? Anyway, whatever. Problem scenario: when main.cpp includes both math utils and geometry utils, the math utils.h file gets included twice, directly in main.cpp and indirectly through geometry utils, because geometry utils includes, okay. So this includes this, and this includes this, okay. So the compilation error, the result in the point structure and the add function being defined twice, when the compiler processes this, it will raise errors such as redefinition of struct point and redefinition of int add int. And these errors occur because the same declarations are processed more than once, which is not allowed for functions and type definitions. Okay, makes sense. All right, so that's why we do that. So that's why that's why we have this in the code. Woo! So that it doesn't call it twice when we call it twice in the things. So there's a piece.h right there. There's a board.h. There's a board.h. So here's two board.h's. So because of that, because of this here, these won't get defined twice. And maybe piece.h2 when we add it into this. All right, so there's that. There's that first thing. So the next one we're going to go and try to learn about is public. So this part. Why this part? And I know there's a private too. So we'll put public / private. All right. So that's what we're going to do in the next one, the public private on ChatGPT. And we'll see you next time.